I'm Ashish Braganza. Can we identify today's visitors that will account for 80% of future purchases? So we're talking about retargeting, display retargeting. And I'm getting into one use case that as to how we're leveraging Syntasa. There are multiple other use cases where Syntasa has actually built clustering algorithms for us that in real time we can personalize the experience when an anonymous visitor comes to the website. For today's visitors, what we said was, what would be random? So if we took all of today's visitors and we randomly retargeted all of today's visitors, so if you took 20% of today's visitors and we randomly retargeted them, the probability is that we would get 20% of future purchases. So it's actually a straight line, and this is just what I'm trying to do out here, and you're going to see it, is like we were trying to build an upper limit and a lower limit for our algorithm. So this is like the lower limit. So randomly, if you just took 20% of today's visitors to the website, and we randomly targeted them, we would get 20%. This is so that was the random event. So what is the upper limit, which is what we call it as the theoretical best case. So the theoretical best case is, we know that our repurchase conversion rate is about 2.5% on average. Now, hypothetically, if by some magic we exactly knew who those 2.5 or on 1,000 for 1,000 visitors, if we knew exactly who the 25 visitors were, and we just picked those visitors and we went after them, we would see this is the theoretical upper limit as to what this is the ideal scenario as to how, if we were extremely efficient, if we knew exactly who the 2.5 were, we'd be able to just target those 2.5. Now I'm going to overlay. Since I've defined my lower limit and my upper limit out here in terms of the in terms of the problem, I'm going to overlay now what are rules today that we have in market that they actually do. So from a rules-based perspective, we have these rules. For example, cart abandoners, product viewers, homepage, and others is everyone. So cart abandoners, what this says is that for 8% of cart abandoners, so for 8% of the population of today's visitors, we can predict we get to date 21% of future visitors. So cart abandoners is doing pretty well. It's above random. When we cumulatively, when you look at product viewers, for 44% of product viewers, it's just about at random. So this is a shot in the dark, so it's just about random. When we add in the homepage at 57% cumulative visitors, somewhere around about here, it's actually below random. This is mapping out our rules-based. So today, for rules-based, if we follow a rules-based approach, in certain rules, we are above, and in most of the cases, we're actually even below random. So now what we did was that we took all our data, and we put it into a logistic regression. We took all the variables, and we got about the top 100 variables, and we got the coefficients and the variables in a logistic equation. And what we found out was that, and so once we got the values, we were able to model it out. So we got an output from 0 to 1, and we created these confidence intervals, which so we created anything greater than 0.9. We were calling it as a high. So we took purchasers and non-purchasers, and we modeled that out into a logistic regression. And we got high, medium, and low is what we've kind of arbitrarily put them into those buckets. So anyone greater than a value of 0.9 was put into the high bucket. Anyone with medium from 0.5 to 0.9 was put into the medium bucket of probability, and then low and very low. And what we found was that algorithmic segments perform really well. So this is the algorithmic segment. So what this says is that for 3% of the population, we're able to predict 55% of future purchases. And then for 9%, a cumulative of 9%, which is somewhere about here, we're able to predict about 80% of future purchases. And with the low, we were able to predict, so only for 22% of today's visitors, we're able to get to 90% of the future purchases. In the test, so this was the modeling exercise that we first did, even before we could drop any media and market or anything of that sort. So we first looked at what is going to give us the biggest bang for the buck. So what we did was that we decided to just focus on the high, medium, and low. We removed the very low because at the end of the day, if you needed to get to a full 100% of future purchasers, this was the inflection point. So we decided to only focus on 90%. That would get us to 90% of future purchasers. The results and opportunities for efficacy. So we reduced display ad costs by 97% by maintaining the same conversion rate. Impression counts for algorithmic segments significantly smaller, yielding a nearly equal number of purchasers. So we had 6.1 million visitors. We got the same level of purchasers, about 39,000. Conversion rate was the same, but our net spend to acquire those customers, we only spent $8,300 on the algorithmic. On the rules-based, we spent over $356,000. In terms of impressions, because it was highly specific and highly targeted to just the 90% that we spoke about, that I showed you, we only needed about 2 million impressions for algorithmic to generate the same level of parity. So we didn't outdo the total size of the pie, but just to maintain, but there was a huge cost savings because we cut out all the waste that was associated with the program.